divide 4 into this 618. Okay, so this is how I learned how to do it. We'll see if this is how you guys learned how to do it. Okay, so you look at the first digit under the division symbol and you say, okay, how many times does 4 go into 6? And I would say 1 time, and then I would write that up on top, and then I would take that number on the top, 1, multiply it by this number on the outside, which is 4, and 1 times 4 is 4, write it underneath that digit, and then subtract to get 2. Does that sound familiar to you guys? Is that how you learn how to do division? It's not. Oh gosh. Okay. Today might be a little bit tricky if that's not how you learn how to do it. So I'm just going to go through this real slow. Once you subtract there, you bring down the next digit in the number. And the reason I'm showing this to you is because this is the process you use to divide polynomials also. So it's same process. So I did 6 minus 4, I got the 2, and I bring down the next digit in the number, so I'm just writing the 1 underneath there. And then you're just going to repeat that process. So you're going to say, okay, how many times does 4 go into 21? So if I said, how many times does 4 go into 21, what would you tell me? 5. Okay, so then the 5 goes up here. And you do 5 times 4, which is 20. You always subtract between each of these steps, so 21 minus 20 would be 1. And then you bring down the next, which in this case is the last digit in that number, which is 8. Okay, and then I'm going to say to you, how many times does 4 go into 18? 4, right? Okay, so then you put the 4 up here. 4 times 4 is 16. And again, every time when you do this, you subtract between these steps, so the leftover there would be 2. Okay, now here's how we're going to do this today. I'm not going to have you do decimals or anything like that. So if you get down and 2 is a smaller number than 4, right? Like 4 does not go into 2 in terms of, it would be a fraction, right? So if you have something that is left over, that 4 won't go into that, do you guys remember what that's called? Remainder. Okay, so this is your remainder. All right, so that's how we're going to do it today with the polynomials too. So my answer here would be 154 with a remainder of 2. And I usually just write R2. Okay, now you don't have to write this, but what it actually means is if I were to take 4 times 154, I would have to add 2 to that to get back the 618. That's what that actually means. If there's a remainder, it means 4 is not a factor of that number. It doesn't divide in evenly. We had extra 2 there. So not a factor, but that's the general process for the division. Okay, so I'm going to try one more with you here. So should always take number on the outside, like look at your first digit. Does 21 go into 6? If it doesn't, just scooch over to the next digit. Does 21 go into 67? And it doesn't have to go in evenly, but how many times would you tell me 21 goes into 67? 3. Okay, and it's not evenly, so you put a 3 on the top here. You can use your calculator if you want to. So then you take 3 times 21, and then you're going to write that underneath. So 3 times 21 is 63, and then you always subtract between these steps as your process. 67 minus 63 is 4, and you just bring down the next digit in the number. We haven't used the 2 yet, and you're just going to repeat the process. You may know how many times 21 goes into 42. Twice. And this is actually nice because 2 times 21 is 42, so that means I don't have a remainder. Okay, so what this means, my answer would be 32. But what it means is if I take 21 times 32, it actually equals the 672. We wouldn't have to add or subtract in if it divides in evenly. So I'm just going to jot this down because this will make sense when we start working on the polynomials. But I would say here 21 is a factor of 672. Anytime you divide in evenly with no remainder, that means that number is a factor of whatever we were dividing. In this case, it was 672. Here, 4 is not a factor of 618 because I had a remainder. Is anybody having a question? Okay, now I'm going to do this process, but it's a little weird because we're going to do it with some polynomials today, but it's really similar to the process of long division. It's just a little weirder because it's going to have some letters in it. Okay, and I'm going to use my highlighter today just to kind of help focus on what questions I'm going to ask you to help solve these problems. And you can have remainders today. Your remainder could be a number. It could actually be an expression. It could be like x minus 5 or something like that. So your remainder can appear a couple different ways. And we're just going to kind of walk through this process with a couple practice questions so you guys get the hang of how to do this. Okay, so I'm going to divide x minus 5 into this polynomial x squared plus 2x minus 30. What you want to look at here, and I'm just going to use my highlighter to kind of focus, you're going to look at the first term, and that's how I'm going to write all the numbers numbers and terms that I'm going to put on top of this is going to be based on that x on the outside, and then the first term under this polynomial. Okay, here's what I'm going to ask you. What would you multiply x by to turn it into x squared? X. Okay, so if I multiply x by x, it would turn it into x squared. So I'm just looking at these two things on the outside. What would you multiply the thing on the outside by to get the thing underneath here? So it's just x. Now, the process for doing this, just like long division, you take that thing on the top and you multiply it by what's on outside. We're going to do that here, but we're going to multiply it by both of these terms. So I'm going to do x times x, which is x squared, and just write it right underneath. And then you're going to do x times this other term, which is negative 5. So x times negative 5 would just be negative 5x. Okay. Now, this is the part that's kind of tricky. So when I do normal long division, you subtract between the steps, and that's what we're going to do here. But this is tricky because we have two terms. So this is x squared minus x squared. So this should go away. That should be, that first step, that should cancel out. If it doesn't, you maybe told me the wrong thing to put on the top. This is the part that's super tricky. Okay, so I have 2x. I'm going to do minus a negative 5x. If I do minus a negative, what does that turn into? Plus. Okay, so really this 2 minus a negative 5 is really 2 plus 5. So when I subtract this here, I'm going to actually get 7x. So you just have to be really careful with that second term. If you could get minus a positive, which would just be subtraction here, if you get minus a negative, you actually end up adding that. Okay, and then like long division, instead of bringing down the next digit, you're just going to bring down the next term. So I'm just going to bring down that negative 30. And I'm going to repeat this process. So just look at the very first term, which you got after you did the subtraction. So I got the 7x there. What would you multiply x by to turn it into 7x? 7. So then up here, just put plus 7. I'm going to do 7 times x, which would be 7x. We're trying to cancel that out. 7 times negative 5 is negative 35. And again, this can be really tricky, so just make sure you're paying attention. The first term, 7x minus 7x, that should just go. That should just cancel out. It's the second term that's tricky. So it's negative 30, but minus a negative 35. So negative 30 minus a negative 35 would be really negative 30 plus 35. So then this is 5 here. Okay, can I multiply x by something to get 5? No. Okay, that's the deal. Then this is your remainder. All right, so here's how I'm going to write my answer. My answer is just going to be x plus 7 with, I'm just going to do like a little r and a colon with a remainder of 5. That's my answer. And then if you want, I'm just going to write down what this means really quick. So what this means is if we took that x minus 5 on the outside times that x plus 7 we got as our answer, we would have to add 5 to that to get back what we had, the x squared plus 2x minus 30. That's what that means. So if there's a remainder, it's not a factor because I'm going to have to add 5 to that to actually get back the original problem, but that's what that means. My answer to the question would just be the x plus 7 with a remainder of 5, but this under here, that's what that means. They don't divide in evenly because I had a remainder. I'd have to add 5 to that. Is anybody having a question? Okay, now I'm going to try one more with you here. This is written just a little bit differently. So this is just written like a polynomial divided by a polynomial straight up like a fraction. What I would encourage you to do here, if it's written in this format, I'm just going to rewrite it real quick. And that 9x, whatever's on the bottom of the fraction would be on the outside if you're doing the division. And whatever's on the top of the fraction would be underneath the division sign. So I'm just going to rewrite this kind of more in the format that first question was. So the 9x plus 4 goes outside, and then this 18x cubed minus 64x squared minus 77x minus 20 would go underneath. All right, so let's see if you guys are understanding this. Okay, so I'm just going to start very first term, which is 9x. We're going to focus on that. And the very first term underneath here. And I'm just going to ask you, what would you multiply 9x by to turn it into 18x to the third? What would you multiply it by? What do you think? 2. We'd have to have, okay, so this is just 1x on the outside. We need 2 more, so we need 2x squared. Does that make sense? We're trying to make it match that. Okay, so 2 times 9 is the 18. X squared times x gives you the x cubed. Then those match up. That's what you're trying to do. You also have to multiply that 2x squared by the 4. So 2 times 4 is 8, and just the x squared next to it. And I'm just lining that up underneath the other x squared term that's in that polynomial that's under the division sign. Now, again, this is tricky, so we're subtracting. This first term, 18 minus 18, that just goes away. Now, this is negative 64 here, just minus a positive. Minus a positive is really just subtraction. So this is negative 64 minus 8. So you're going to get more negative here. This should be negative 72x squared. And if you want, feel free to use your calculator, but that would be negative 64 minus 8. So I'm going to get negative 72. And then the x squared with it. Once you got that, just bring down the next, instead of the next digit, you're going to bring down the next full term when you're working with a polynomial. So I'm just bringing down that negative 77x. And then we'll just go through that process again. Okay, what would I multiply 9x by to turn it into negative 72x squared? Colton, what do you think? Say that one more time. Okay, good. I didn't hear you say the 8. Negative 8x. Okay? Now, negative 8 times 9 is negative 72. X times x is x squared. So that gives you that negative 72x squared. Now, negative 8 times 4, negative 32, and then we'll have an x with that. Okay. Now, I know this looks a little weird, but negative 72 minus the negative 72 is really negative 72 plus 72. So this is gone, which is what we want. And if you want to just work with the coefficients, I got negative 77. I'm not on the screen, fail. What is this? Okay, I've got negative 77. You guys can't see that. And I just made that 100 times worse. Maybe. Sorry, I'm trying to get it so you guys can see it. There we go. Negative 77, and then I'm going to do, if you want to just do it right on here, I can just do it as, I got my second, minus a negative 32. Really, minus the negative is really plus, but if you want to do it on your calculator, feel free. So I'm subtracting negative 32. It's really negative 77 plus 32. So it's still negative, but it's 45x. And then you're just going to bring down that next term. This will be our last step. Okay. Now, once you do the subtraction, you are literally just looking at the first term here and the first term outside of the original problem. What would you multiply 9x by to get negative 45x? What do you think? Positive or negative? Just got to use a negative. Just got to get negative. That's it. Negative 5. Negative 5 times 9, negative 45, and then times the x, so negative 45x. Negative 5 times 4 is negative 20. Okay, now everything matches here. Both of these are minus a negative, so these all cancel out. So this means I have no remainder. is what, you don't have to write that out, but that's just, that would be 0, would be left over. So there's no remainder for this problem. So my actual answer to the question is the 2x squared minus 8x minus 5. And I'm not on the screen, forgive. Now, what it means if I take 9x plus 4 and multiply it by that 2x squared minus 8x minus 5, that would exactly equal what we had. And you don't have to rewrite this, but that would exactly equal that polynomial that we had under the equal sign. And both of those would be factors of that polynomial. So the 9x plus 4 would be a factor, so would the 2x squared minus 8x minus 5. They're both factors of that polynomial. Is anybody having a question? Okay. Now, if a question asks you if something is a factor, which is what you're going to see in these two here, right here at the top, which we're just going to practice division again on these questions. So, if it is a factor, then you can determine that if you have no remainder. So something will be a factor of a polynomial if you have no remainder. So if I have no remainder, my answer will be yes. If we end up with a remainder when we do this division, then our answer would be no. So if there's a factor, it divides in evenly with no remainder. So this guy here says determine if x plus 4 is a factor of either of these polynomials. So I'm just going to write them both out here real quick. And the x plus 4 would be what we're going to divide into the polynomial they give us. So I'm going to put x plus 4 on the outside, and I'm just going to copy down that x squared plus 6x plus 8. And we're going to divide this. If we get a remainder, our answer is going to be no. If we don't get a remainder, then our answer would be yes. And just while I'm up here, I'm going to copy it for this one too. I'm also going to divide x plus 4 into this guy, which is x cubed plus 3x squared minus 6x minus 7. So we're just going to practice this a little bit more on the back here. All right. So totally just focusing first term and first term. What would you multiply x by to turn it into x squared? Just an x. So just put x up here. Okay, now that gets multiplied by both guys on the outside. So x times x is x squared. X times 4 is 4x. And then once you set that up, you've got to subtract both of those guys from what you had underneath the division sign. So x squared minus x squared, gone. That's 0. 6 minus a positive 4 is really just 6 minus 4. So this is 2x when I subtract that. And once you subtract, if you have another term, which I do here, which is 8, just bring that down, and then we'll repeat the process. So then I'm going to ask you, if I take 2x, what would I need to multiply x by to turn it into 2x? 2, just plus 2. So put that up on the top. Now, 2 times x is 2x, and 2 times 4 is 8. So actually, when I do the subtraction here, both of these guys cancel out. Oh, go ahead. Yeah, go ahead. Go ahead. Okay, so both these guys cancel out, so no remainder. So my answer to the question is yes, because I did not get a remainder. So that means that x plus 4 is a factor of that polynomial. If you guys want to write it out, it just means x plus 4, if we would FOIL this, it would give us back the x squared plus 6x plus 8. And that makes sense. If you want to think back to our factoring, multiply to get 8, add to get 6, 4, and 2. So I know that that's a factor there. No remainder. We wouldn't have to add or subtract anything to get that to match the polynomial underneath our division sign. So my answer to the question is just yes. All right, so we're going to do one more. This one's got a little bit higher power of x here. So what would I need to multiply x by to turn it into x cubed? Should you multiply x by, go ahead. X squared, heck yeah. All right, so x squared. Now that gets both multiplied by both guys on the outside. So x squared times x would give you x cubed, that's what we want. X squared times 4 is 4x squared. I'm just going to line that up underneath that 3x squared from the original problem. And then just remember the process of long division. When you're doing this, you subtract between each of these steps. So I got 3 minus a positive 4. It's just 3 minus 4. This would be negative x squared when you subtract it. Negative 1, if you want to write the negative 1, that's fine. You just bring down, if you got it, the next term, which for this polynomial, that's negative 6x. And I'm just going to go back through that process. What would you multiply x by to turn it into negative x squared? Negative x, perfect. All right, so negative x times x, negative x squared. Negative x times this 4 is negative 4x. And then just remember we're subtracting here between each of the steps. So minus a negative, this would cancel out. Now here, negative 6 minus a negative 4 is really negative 6 plus 4. Whenever you do minus a negative, if you don't believe me or if you want to check on your calculator, I'm doing negative 6 minus negative 4. It turns into a negative 2 because it's really adding. And then I would bring down, we got one more term here, which is that negative 7. Okay, what would you multiply, just looking at the first term there, what would you multiply x by to turn it into negative 2x? Negative 2. Negative 2. All right. Now, negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. Now, I subtract here. These go. This is really negative 7 minus a negative 8, so negative 7 plus 8. So this is 1. X does not go into 1. That would be my remainder. So my answer, it's asking if this is a factor. If you have a remainder of any kind other than 0, then it's not a factor. That means it doesn't divide in evenly. We had this extra 1 for this question. Is anybody having a question? Okay, let me try 2 more with you. These are both kind of just like weird things that might happen, kind of a thing for these last 2 examples. So example 3, this says divide, but I have missing powers of x. And so what I mean by that, like if you guys look at this problem, right, underneath here, I've got x to the 4th, but then there's no term that has an x to the 3rd. And then I got an x squared, but then I have no term that has an x. And then I have a plain number, my constant is negative 10 there. So just to take care of that, what I would recommend if you get a problem like this where you're missing a power of x is to add in, I'm going to add 0 with whatever x I'm missing. So here's how I would rewrite this really quick. And this will make so much more sense when we start doing the problem, but it's really just to help you line up so you can subtract easier. Okay, so I have an x to the 4th, right? I'm really not going to be adding anything here, but I'm going to add a place value is what I'm really doing. So I don't have an x cubed term, so I'm going to write plus 0x to the 3rd. That really is equal to 0. I'm just putting this in here to help for place value. All right, then I have negative 3x squared. So I'll just go ahead. So I'm just trying to make it so I have all the powers of x, and if I'm missing any, we'll just replace it with 0. Now, I don't have a plain x, so again, I'm going to put this in here plus just 0x. I'm really adding 0 there. This is just to help you organize when you do the subtraction. And then I had my constant, which is negative 10. So that way I have all powers of x. Like just a plain x would be 1, squared 2, cubed 3, and then the 4th. So let's see if we can do this process again. Now, what would you multiply x by here to turn it into x to the 4th power? What would I have to multiply x by to get x to the 4th? X to the 3rd, perfect. Okay, now this is going to make more sense why I just did that. Okay, x to the 3rd times x, that's x to the 4th. When I do x to the 3rd times this negative 2, it's negative 2x to the 3rd. And I can line that up under what I put there with the 0 just to kind of help me think through how I would subtract that. So that's really what that is. All right, x to the 4th minus x to the 4th goes away. That's 0. If I set this up, this is just to help me. So this is 0 minus a negative 2. So 0 really plus 2 then. Minus a negative turns into a plus. This would be 2x cubed. And then just like we've been doing, just bring down the next term in the polynomial, which was negative 3x squared. And we'll repeat that. So tell me what you would need to multiply x by to turn it into positive 2x cubed. What do you need to multiply x by to get 2x cubed? Two x squared. Good. All right, so 2x squared. 2 times x, or 2, just right there is just 2, and then x squared times x gives you the x cubed. Now, you have to do that by the 2 also, so 2 times negative 2 is negative 4, and then we'll just have an x squared with that. Always subtracting between the steps. If I've done this correctly, then these guys should go. And I get negative 3, now tricky here, minus a negative. I literally like make myself touch that subtraction sign so I don't forget this. So this is negative 3 minus a negative 4, so it's really negative 3 plus 4. So this would actually be positive 1x squared. And then I know we added this in, but just to help us with the place value, I'm going to bring down that 0x that I added in since we didn't have a term that had a plain x. What would I multiply x by to turn it into x squared? X. So just plus x next here. On the top, x times x, x squared. And x times negative 2, again, negative 2x. That 0x we put in at the beginning of the problem is literally just to help us with the place value here when we do the subtraction. So this guy, I've got 0 minus a negative 2, so it's really like 0 plus 2. So this would turn into 2x. And then I'm going to bring down this final term here, which is negative 10. And I promise this is the last step. What would you multiply x by to turn it into 2x? Just a 2. So just plus 2 up here on the top. Now, 2 times x, and I'm writing too big, is 2x. 2 times negative 2 is negative 4. And if you do the subtraction here correctly, and people get tripped up by this, you do get a negative number. So this 2x minus 2x, 0. Negative 10 minus a negative 4 is really, bless you, negative 10 plus 4. So this ends up being negative 6. Don't be tripped out by that if you get a negative number for your remainder. That is completely fine. If you're working with normal digits that don't have a polynomial involved, that's not true. You're not going to get a negative remainder, but you can get that when you're doing polynomial division. So my answer to the question, forgive, I'm not totally on the screen here, would be x cubed plus 2x squared plus x plus 2, and then my remainder, totally fine for that to be a negative number, would be negative 6. And I usually just write like r and a little colon. If you want, what this means is if I multiplied x minus 2 times that x cubed plus 2x squared plus x plus 2, we would just have to subtract 6. That's what it means if you get a negative remainder. Instead of adding it, we'd have to subtract it to get what we had, that x to the 4th minus 3x squared minus 10 that we had in the original problem underneath the division sign. So it's totally fine to get a negative remainder. Is anybody having a question? Okay, now I have one more. This one is just a little bit weird in terms of kind of how these terms go as you divide here. So we're actually, all the ones we've done so far, I've had like a linear binomial. So just an x and a number that we've divided into each of the polynomials. This last one I have a quadratic. So this has got an x squared plus 4 that we're going to divide in here. So I'm just going to rewrite this real quick so it's more in that format we've been doing all the other questions, just kind of set it up for long division. So whatever you're dividing, whatever's underneath, that would go outside the division symbol, and then on the top, that 4x to the 4th, 5x cubed, 10x squared, 20x, and then minus 20 would go underneath. Okay, now this is going to be a little trickier because we're working with an x squared. So for all these questions, you want to tell me, what would you multiply x squared by to make this happen for the multiplication? Okay, so what would I multiply x squared by to turn it into 4x to the 4th? Yeah, 4x squared. Okay, now this is tricky. So 4x squared times x squared is 4x to the 4th. But when I go ahead and multiply 4x squared times 4, 4 times 4 is 16, times x squared would be 16x squared, which I'm going to line up way down there with the other x squared term. So that's why this one's a little bit weird. Now, when I do the subtraction here, this is just going to go. Basically what I have here, I don't have an x cubed term to subtract, so you don't want to forget about this. I'm just actually going to bring this down. So I'm just going to write this 5x cubed just underneath there. There was nothing we subtracted that from because we didn't get an x cubed term. We did get a squared term, so this would be 10 minus 16. So this is going to be minus 6x squared. And I'm going to go ahead bring down that next term, which was the 20x. Okay, I know this has 3 parts, but this will make more sense when we go ahead and do the next step. So don't forget about the 5x cubed. There just wasn't anything to subtract from that in that first step. What would you multiply x squared by to turn it into 5x to the third? What do we think? 5x. Okay. So I need a 5 and I need another power of x. All right, 5x times x squared is 5x to the third. Now, this is the reason I brought down that other term. 5x times 4 is 20x. So I'm going to line that up with that 20x. So this is really similar to that last step we did where we just don't have a squared term, but we don't want to lose that. So this goes, I just bring down, there was nothing to combine that negative 6x squared with that, so we're just going to bring that down. And the 20s actually cancel out, so that's just gone. And I do have one more term from that original, bless you, polynomial, which is just negative 20, bless you. So I'm just bringing that down. Okay, what would you multiply x squared by to get negative 6x squared? Sorry, I should highlight that. What would I multiply x squared by to turn it into negative 6x squared? Just a negative, you don't need another x, just a negative 6. So negative 6 times x squared, negative 6x squared. Now, negative 6 times 4, negative 24. So this is not a factor because I'm going to have a remainder here. So I get negative 20 minus the negative 24, which is really negative 20 plus 24. So this is 4. X squared definitely does not go into 4, so that's going to be my remainder. So then my actual answer to the question, it's what you got on the top, the 4x squared plus 5x minus 6, and then it's not a factor because we have a remainder of 4. Is anybody having a question?